issue with Git. Like some people had some changes in Git that they commit and they don't know why it's there and why it has their names on the commit. There are also some people who commit changes that are not supposed to be committed. There are also people who format the whole source code file and commit the whole file, which means the diff is like everything was removed and everything was added, which is not readable. So in those cases, if we do code review, then you basically screw up because you don't use Git properly.
Oh, you really make a slide for that?
It's simple, 4 slides. Okay, so this slide, the purpose is to show you how I'm going to find out who screw up and how you can avoid screwing up. Like if you screw up, people can find out. They will find out. Okay, and it will make you look bad. So use the techniques to make you don't look bad.
Yeah, to hide your phones.
Yes. Okay. Yeah. So there are 3 main ways that I will find out who screw up the code. This is supposed to be done when we have a bug, and depending on the level of the bug, we do different techniques for you.
Different technique to fuck you.
The first thing is extremely simple, a blame. Okay. Anyone here who doesn't know about a blame?
I'm blaming you.
Okay, blaming. Okay, so a Git blame looks like this. So you tell Git, hey, look at this file and tell me who changes each file in the each line in the file. So it will tell you these are the people who is responsible for each line. So you can see here, most of it is Brandon, some is mine, some is Tonan.
Most of the Brandon thing is actually mine.
So if you look at the blame, and if you know where the error is, like you open the file, you see a stupid mistake, then you do a blame, you know right away who's responsible for the stupid line. You see? So this is the simplest, but it's only applicable when you know which line, which file is stupid. Okay. Next is bisect. Some people here have seen the bisect. Okay. At least Phúc Khang. Long. Okay.
Oh, so actually that's noisy from Phúc Khang, right?
Yeah.
Yeah, Phúc Khang is funny. But you
Everything.
yes. So a bisect is supposed to find the error. So suppose you find an error and you don't know where it comes from. You don't know what makes it wrong. The bisect will help you find it. The way it works is you look in the past and see a version of the code that works. And you look in the present where the code is not working. You tell Git bisect what's happening.
Just continue.
Okay, so you tell Git bisect, here's the good version, here's the bad version. Find me the version, the oldest version that is bad, which means the first version that is bad. So say you have an older version that works, you have a newer version that doesn't work, then you tell Git, here's the good version, here's the bad version. Tell me the first commit that is bad.
The first one that modified that piece of code.
No, the first one that is bad, which means the first one that makes the code runs incorrectly. So what does Git bisect does is from the newest, like the bad to the good, it check out the one in the middle and it asks you, is this commit good or bad?
Ah, okay.
And then you answer yes or no.
And then it look.
Yeah, and it continue checking out the one in the middle, and it asks you again, is this commit good or bad? After a few answers, most of the time it's less than 10. Like in 100 commit, then maybe it check you
50.
Really?
I don't know.
The number is pretty small because it's a logarithm of 2. So you very quickly you will find out what commit is wrong. At that time, Git will tell you this. This is the first bad commit with the name of the person. You have your name on it, and the date, and the message, and the ID. So this was a case that happened to Phúc Khang where I do a git bisect and it landed on one of his commit and it say this is a bad commit. Okay, and at that point it was even worse because Phúc Khang looked at the commit and say this is not mine, which is not acceptable. It has your name on it. Okay. Okay, it has your name on it. You are responsible for the commit that has your name on it. So that's one thing that you cannot avoid.
Yeah.
The third one is actually a combo for this one. Like you see the commit that is wrong. You want to see what is wrong. So you do git show, and git show will give you something that looks like a diff. So it also has the name and whatever and what is changed. Like red is removed, green is added. So it's basically like a git diff, but it does it for certain commits.
For this commit and the rest
No, if you do git show and the commit ID, then it just shows the changes that appear in that commit.
Okay. Yeah.
So this effectively pinpoint the point in the code that is wrong. I think unrelated to this is to make things easier for tracking down bugs, you should make your commit relatively small. It doesn't have, a git show doesn't have, if your commit contains changes to a dozen files and each of them contain changes to hundreds of lines, then a git show doesn't have much because it's too big anyway. You know that commit is bad, but you don't know how to fix it. You need to read through all the changes, and that is bad. So one point is make your commit small.
Yeah, rule of thumb is like you commit in like every small feature or in every functions. After finishing the function.
Like after you've done everything that is meaningful, even small.
Yeah, if it has a meaning, commit it.
Okay.
If you do whole day long and you cannot commit it, you are doing something bullshit.
Okay. So again, the three tools are blend, bisect, and show. So I have all the tools that I need to track down who done it wrong.
To hunt you down.
Yes. So you also have the tools to avoid that. By avoiding, I don't mean you do it wrong and you avoid being caught. By avoiding, I mean you fix it before people find out.
I have a solution. Go to dev server and do it like rendered.
Oh fuck. That's why I hate the dev server. Okay.
I have only been on that server
Okay.
since I
So
ever joined.
you also have tools to see what thing you have done and avoid being caught by other people. They are also depending on the level. This tool is probably the most basic thing and the one that you should use all the time. Unless you are very accustomed to reading diff.
But we can.
As you can see, reading a git diff is not always easy. It has red lines and it has green lines, which means some line was deleted, some line was added, but it doesn't tell you where is where and which part matches which part. The diff tool is supposed to fix that. In my toolkit, diff tool is Vim. So the diff tool will generate two versions of the file, one that is old, one that is current, and it open in two panels. All diff tools can do this.
Yep.
All diff tools can open the file in two panels and let you compare the two versions line by line. So in this case, you can see that this is the old version, this is the current version, and it's very clear that you have been adding this part, you delete this line, you delete this part. So it becomes perfectly clear to you that these are the changes that you made. So you can avoid testing code that is left inside production code. Like if you see this and you see some pieces of code that doesn't look right, then you edit it right here. You delete things, you fix it right here before you even commit it, let alone pushing it. So this is the basic tool that I recommend you run unless you really know how to use a git diff. If you remember, a git diff looks like this,
Like that.
which is not intuitive.
Yeah.
So find a diff tool that you like, okay, and use it oftenly.
I heard Tung An say something about like it.
Okay, fine. I'm fine with that. The second thing is a merge tool. A merge tool, as its name suggests, it helps you to merge. So say you are merging two branches and you have a conflict. Then normally you will open the file and find something with a lot of smaller than and a lot of greater than, and fix the thing in between. The same logic applies. It is also unintuitive, as the same as the git diff, and the merge tool is going to fix that. Again, my merge tool is also Vim.